Well, hello everyone, and welcome back to Adrian's Digital Basement 2. This is a second channel video, yes it is. And today we're going to be looking at this. This is a Freedom 100 terminal from Liberty Electronics. This terminal was donated to me by a local viewer, thank you very much. And as you notice, it has a removable keyboard. Well, it's not connected. And let's take a look at this thing. I haven't turned it on. I don't know if it even works. Maybe it's burnt out, the screen is dim, who knows? You may notice right off the bat that it is missing some keys. Luckily, just to kind of get this out of the way at the very beginning, I have the keys. The problem is the stems are broken on the switches. We'll look at that in a second, but that may make it next to impossible to restore this keyboard, at least back to full functionality. So first off, let's just take a quick look at the terminal itself. Move the keyboard out of the way. All right, so the terminal, I'm gonna say, well, I can't tell if this is a green or amber screen, but I at least am not seeing any massive burn-in while this thing is off, so that's a good sign. It's got this tilting front stand thing right here, so if I lift the monitor up, or the terminal that is, that thing kind of clicks into a position like that, and now it tilts this thing up. I think it's basically just got that position, and if we put it forward, that position. So it's just got those two spots. We tilt it back up again. It has a sticker right here. It says adjust contrast control. So that's for the monitor. I think that it would be the only control on the front. Yeah, nothing else that I can feel. Funny that whoever had this thing never peeled that sticker off, or maybe that was on purpose. Of course, on the side of this thing, there is nothing to see. And on the back, we have the fixed power cord, which is wrapped around. There is the power switch there, a fuse, a voltage switch, and then a whole lot of ports and dip switches. As is pretty typical with these, there's an aux port and the main port. The aux port would be for connecting a printer, a serial printer, while the main port is your serial connection to your mainframe or Unix box or whatever this thing is going to be used with. And then you'll notice all this text here. This is talking about the configuration options, which are available by setting these dip switches. Relatively standard stuff. Baud rate is 19,200, decently fast for how old this thing probably is. It seems some international character sets are supported, including Japanese. That's relatively cool. Screen frequency, which maybe changes the refresh rate, interesting. Busy label, I'm not sure what that means. And then we have emulation, which I guess these top three settings are unknown. There we go, Televideo 910, Hazeltine, Ads Regent 25, ADM 3A/5, and a Freedom 100. And that is what this thing is. So this obviously has its own mode. We have some cursor settings, line truncate, which probably means auto wrap or not, half or full duplex, and then we have the main serial port, baud rate and whatnot. So the one that we saw over on the left was actually for the auxiliary port. Unfortunately, the label has seen better days. I wonder why it's all ripped up like this. But there is Liberty Model BT1200A. I assume Liberty Electronics Corporation, probably Taiwan, and unfortunately, the manufacture date has been torn off. There is, let's just tilt this thing up and see if there's anything to see on the bottom. And nope, there is not, just that tilting bail thing. And then looking at this side of the terminal, there is the connector for the keyboard there. It's a little phone jack style one. And this interesting sticker here, the Cousteau Society, 930 West 21st Street, Norfolk, Virginia, 23517. Anyone have any idea what that's about? So I think, as I mentioned, this was given to me in unknown condition. I have no idea if it works or not. And you know what? I'm just gonna plug it in and turn it on and see what happens. Let me just reach behind and hit the power switch. Seemingly nothing. Although, I think the keyboard, which I haven't looked at yet, the beep speaker, is on the bottom. Oh, hey, I turn up the contrast, and there is a flashing green cursor right there. So let me turn this off and plug the keyboard in. Let's take a look at the keyboard here. The camera focuses, there it is. Block, escape, you know, various keys. We got a whole set of function keys up to F10. Arrow keys are on the top row there, very much like the Commodore 16. Rub out. Don't forget to rub out your, you know what. Backspace says back and space, 2 lines. I think the keys are definitely, they've yellowed. They were gray originally. And the number pad there, it's got some various keys on it, but it's definitely not VT100. And we saw on the back, that is not one of the emulation modes for this thing. And on the flip side, there is the serial number and the Freedom 100 sticker. And it looks like the speaker is inside the keyboard. The interface cable's fixed, which is actually kind of nice, because those are something that typically would be lost or whatnot. But if we look at the end, it just is the same size jack as like a telephone handset. So we'll just pop this into the side of the terminal there. From a feel perspective, it's okay, I guess. It's not terrible. And when I mentioned the yellowing, maybe you can see that there. So these keys, sort of a brownish gray was the original color. You may just be able to make out that the stems are broken off inside of these keys, right in the center there. This one as well. So I probably can get those out using a little screw. But then the problem is the stems on the keyboard are gone. And I will talk a little bit more about that briefly, but let's just see if this thing even works, because if, of course, the terminal's dead, there wouldn't be any reason to even try to fix the keyboard. All right, here we go again. Oh, okay, it made a beep out of the keyboard, so just as I thought. So there are no keys on the keyboard that seem to bring up a menu, but I did something that now allows me to see what I'm typing. I gotta say, oh, there's a deflection problem with the monitor, all right. So it's all squished. This is the top of the screen, should be up there, and the bottom, it's not even deflecting. So vertical deflection is screwed up on this thing. Let me just turn this down. I don't want it to potentially damage the screen. Yeah, I can see the letters are very squished. Very nice and high-res text, though, I must say. So, all right, let's pop this thing open. A vertical deflection problem is usually a little bit easier to fix than, say, horizontal. I mean, it's not that either of them are ridiculously difficult to fix. But when you have vertical deflection, that is just running at 60 hertz, or 50, I guess, depending on the switch on the back. So typically these older monitors just use 2 transistors, power transistors, like maybe audio amplifier ones. Because if you think about 60 hertz, that's in the range of audio. And you just have like a pair of them, a PMP and an NPN. So it's sort of a push-pull situation. So your retrace line's in the center, and one of them pulls it up to the top, and one of them pulls it down to the bottom. So it's very much just like an audio amplifier. So it's nothing too complicated. So probably, well, you know, we have to scope and see what's going on, but there's a good chance that one of those is just dead, maybe shorted, and that is causing it to not have proper deflection. Now, when horizontal deflection has a problem, then generally the whole screen won't work, and that's because the horizontal is usually generating also the high voltage going through the flyback transformer, because that's running at like 15 kilohertz or 20 or whatever, something like that. It depends on the monitor. So it's good to see that obviously there's good brightness here. There is good horizontal deflection, definitely looked fine, and we just simply have a problem in the vertical stage. Okay, so those screws are off. This just comes right off nice and easily. Hey, that's actually looking quite nice in here. I'd say that this thing doesn't have a whole lot of hours on it. I mean, it's dusty, but this CRT, that looks good. That looks strong. That's exciting. So looking at the main board here, it's pretty typical stuff here. There's a 6845 CRT driver in the back there, and we have a 6802 here and a 6821 there. The 6802 is the 8-bit CPU that this thing is running, and it's part of the Motorola 68000 family. I think according to Wikipedia here, the 6802 is very much like a 6800, but it includes 128 bytes of RAM and an internal clock oscillator on chip. So I guess that alleviates the need to have external RAM on this thing. Well, it's obviously going to have a RAM for a video buffer, but maybe it doesn't need a whole lot of RAM for running the rest of the terminal. I don't know. I see right off the bat, these two chips here are static RAM chips, so it's got SRAMs, but there's a couple EPROMs there, and there's another one back there. So one of those is going to be for program code, and maybe these two over here are going to be for the character display, the selectable fonts that you have by flipping these switches here. This is the power supply board. It has a large transformer underneath here. So there's a mains transformer that then goes to this power supply, which is probably has some voltage regulators on it. And yep, I can see them sort of back there. So this will generate the 5 volts for the motherboard, but almost certainly it's generating some minus and positive voltages for the serial ports, because RS-232 is, I think, typically plus or minus 15 volts, 12 volts, something like that. So it's going to have that. And there is nothing from the power supply that goes over to the monitor board, which is the one on this side. So it obviously is getting its power off the motherboard. It probably runs on 12 volts. So first step to try to do this repair is I got to get this TV board out of here. So let's just pop the CRT connector off. And I'm going to have to cut a couple of these little zip ties here and take out this bar. It looks like this will slide out the top. From a manufacturer time perspective, looking at some of these ICs as I remove these screws, I'd say 1983. I see some chips, I see a bunch of chips that are soldered on the board from 83. Okay, I just realized, I think the actual correct way to get this board out is to remove these 2 screws, which releases this little white plastic piece here, which looks like it holds the analog board in, or whatever, the Crt Driver Board, let's call it. And then I'll use these to cut through these zip ties here. So this thing comes off, that's the little holder. And I think this board should slide forward. It does indeed. I'll just need to cut through a couple more zip ties first. I know you're not able to see very clearly, but I'm just removing a couple connectors. One is the ground lead, this is the deflection. And what else can I unplug here? That's fine, and this is the motherboard connection, and that is soldered on, so I'm going to have to pull this off. This cable here that goes to the front is the contrast and brightness knob. Now it's interesting, it goes to the motherboard, not to the CRT board. Okay, so this is free. All I need to do now is remove the high voltage anode cap. So I have the high voltage probe here. It is connected to the ground point right here. Let's just get this underneath here. I doubt this has any charge. Even though I was just running it, it does not have a charge. A screw just fell out of something, and where was that? Okay, I don't know. I think it might have fallen out of right here. This cap is very sticky, and that happens over time. And I found that a solution, it's kind of hard to get to because of this bar that I've only partially removed. You know what, I'm taking the whole bar off because it's kind of in the way. But I found a good solution to get rid of that stickiness on the cap is WD-40. It really cleans off the kind of stickiness, and I mean, now it's all over my fingers. Ugh, it's really gross. I assume it's just like the rubber or whatever it is degrading. I don't know if it's gonna turn to total goo or this is a process that is okay. I don't know, but the WD-40, like I said, seems to clean it at least. But it's so sticky, it's actually like dripped down the CRT, and it's really hard as well. I can't even see under here. I gotta like get it unhooked. There we go. Come on. I know you want to come out. Without, oh, it's so sticky. There it is, very, very sticky. Let's do the WD-40 trick, and I've got to clean my hands first. What's funny is I just washed my hands with soap and water, and even after, it's still horribly sticky, the residue. So if anything, use WD-40. So I'll just spray some on this towel here. And I'm gonna use this to try to like clean up what's on the CRT as well. Like, you know, WD-40 is a pretty good solvent. Yeah, and it's getting that off of there. I'm just gonna give this one more hit with that. No, it was fine. Sometimes the CRT can actually build up a charge again, just sitting there. Look at that. Look at that. Gross. So what I'll do is I'll hit this first with this WD-40, get the sticky off, and then I'll use Windex to clean it up the rest of the way. All right, and then this, same thing, you just kind of wipe this. Obviously, if you're wearing gloves, that can help. Not get your hands covered in the sticky. Okay, so now that's clean. I have some Windex on this. I'm just gonna clean this off. It was black, but I'm gonna use the Windex just to kind of clean the WD-40 sticky, oily residue off this, the CRT and off the cap, because there's no need for it to be oily. So I'll just give this a little clean with the Windex. There we go. It's nice and clean now, and it's not sticky at all. My fingers are still sticky, but this isn't. It's still not super flexible. But anyways, okay. This board should just come right out now. There it is. So that's the Crt Driver Board. And I gotta say, these are kind of like jelly bean parts, this entire board. I think several companies made these back in the day, and companies would just buy these. In fact, see this sticker here? It says 8305. Well, it's probably when this was made, the 5th week of 1983. Underneath there is this slotted edge connector. Now, if you've ever worked on, say, something like a TRS-80 Model 3 or Model 4, it has one of these boards, very similar to this. I'm sure it's not exactly the same, but it's very similar. On the side of the case, I'm trying to think of how it is. So if the monitor is in the front here, this is mounted like this, and there's a connector that slides over this that goes to the motherboard. It slides over this thing. But yeah, like I said, these were pretty common. They were pretty common on all of these terminals. Now, of course, they were probably customizable to some extent, because this thing probably runs not at 15 kilohertz NTSC, but like at 22 kilohertz or 20 kilohertz. And I think, you know, different components on this would determine what scan frequencies it supports. But yeah, anyways. All right, so from a fault perspective, there's a couple possibilities. Well, I mean, I don't really know exactly what's wrong, but this transistor right here, this is for horizontal drive. Definitely horizontal. It's got a big heatsink on it. This one over here, this little one there, has its own small heatsink. This is the vertical drive. Now, it's a multi-pin thing, and that's problematic for me, because if that is dead, like say half of it's shorted, I will have to find an exact replacement or something compatible. It's an NEC part. So yeah, so I think I'll just have to try to look at my spare parts bin, see what I can find. But before I do that, actually I need to start checking this thing with the multimeter and look for shorted components, shorted semiconductors, diodes that are bad, shorted, the transistors could be shorted. Okay, I looked up that multi-pin part that I said is for vertical deflection, and sure enough, it's a bipolar analog integrated circuit here. It's the UPC 1031H2 vertical deflection device for monochrome TV and small-sized color TV. Now, fortunately, this block diagram kind of confirms to me that this is probably bad. The reason why is on the input is simply the vertical synchronization pulse. This is coming from the motherboard. It's just the V-sync. Normally, you have a little bit more electronics that are separating that out and then driving large power transistors that generate the deflection. But on this, there's a vertical hold pot right here, and the V-sync pulse goes into it. And there's some oscillators and various components inside this thing. There's a V-sized pot down here that's hanging off the chip as well. And then that all goes into the power amp stage inside this IC. And then out comes literally the deflection signal that goes to the yoke. So over here on the right side is the yoke itself, and it has the deflection signal that should be going to it. So I'm gonna do a quick inspection and make sure there's no broken solder joints under here, because maybe there are. I guess I should check to make sure that these pots are working. I can just check them with a multimeter, make sure that the pins going to the IC are seeing that. I mean, it's possible the V-size is not connected, and maybe that's a symptom with that really squished picture. It's probably possible to still buy that IC, so I could fix this thing, but I certainly can't do that in time for this video. So I think I'm just gonna start probing around on the bottom here and just checking to see if I have any bad solder joints, and then I'll try to fix them, and I'll check those pots and stuff like that. Well, unfortunately, I finished going over this board and I don't see any issues. I've gone over all these caps in this area. Everything is fine. I've checked these potentiometers here for linearity, size, everything. They're good. No bad solder joints. The tantalums or the ceramics that are here are fine as well. Resistors are fine. Everything in this area looks completely in spec and without issue. All that really leaves us with, well, there's still a possibility I have something to try when I bring the monitor back over here. But either this IC is bad or the deflection yoke, perhaps it's shorted or something like that. So I will check it with the LCR meter here, because I should be able to check the millihenries reading on it. According to the data sheet here, I think it's 2.7 to 4.15 millihenries is the inductance of the deflection on the vertical pins. So I'll test that out. So the LCR meter is set to auto. This is a deflection yoke connector. It's the center 2 pins that are for the vertical, which is what we're looking to see what it reads as. And I'm using these very pointy multimeter probes because that should plug in. We're getting 10.16 millihenries, and actually I'm looking at the data sheet again on behind the monitor here, and it says 4 to 15 is good and 2 to 7 ohms. So let's switch this thing to resistance. Here we go. We're getting 35 ohms, which does seem a little high. I wonder what the deal is with that. Nope, 22. You know what? I'm just going to, just for my sanity, I'm going to use the multimeter to check the resistance. I never generally use the LCR meter for any kind of resistance measurements, so I'm not really familiar with it, like if it reads the way I expect it to. Okay, yeah, so it reads weird. On the regular multimeter, 9 ohms. 2 to 7 is what it says on the data sheet. Let's just check the connections here that they're not loose. 8 ohms. All right, well anyways, I don't know, I'm gonna reconnect this thing together and we'll just take a look at how the image is, see if my fiddling had any effect whatsoever, like maybe it was a bad connection. And the only thing I haven't checked is I haven't checked the voltage input on the Crt driver board. Maybe it's not getting the correct voltage or something. I mean, that's possible the power supply is having a problem in this machine and that's causing an issue, but I don't know. I'm not holding my breath. We'll hook up the Crt ground, hook up the deflection yoke. We'll connect up the neck connector here. It's not a neck board, it's just a connector. And of course, we gotta hook up the high voltage anode. Not sticky at all anymore. All right, I'm just gonna turn this like so, and I'm gonna look in the CRT. You're not gonna be able to see it in the camera, but I will take a look. Just a last double check that everything is reconnected here before I power this on. Yep, I think we're good to go. Okay, here we go. Yeah, unfortunately, no change. I'm just gonna fiddle with the linearity control here and see if this has any effect. No, that has no effect at all. Vertical hold. Vertical hold sort of moves it around a little bit. And what's the vertical size here? Well, the size control definitely has an effect. I personally feel it's highly unlikely that anyone has fiddled with the controls. But even if it was fiddled with, it shouldn't be all squished at the bottom, but not at the top. So I'm just plugging the keyboard back in, and I'm gonna flip this switch up here, which should turn on half duplex to allow me to type. All right, come on, wake up. Okay, so I'm typing on the screen. Let's just see how this looks. Okay, so let me turn this so you can see what's happening right now. Okay, so you see here, it's all squished again. You know what? It's actually changing as it just sits here. Okay, so It's basically the deflection's actually wrapping around because these letters here are upside down. So let me just fiddle with the controls on the top here. So this is the size control. And you see how it's like got this weird delay action going on? This is kind of how it was when we started using the screen. So instead of going down and deflecting all the way down, it sort of stops and starts coming back too early. And that's causing it to wrap around. So when I go like this, yep, those letters look good for a sec, and then they start to get screwy. Now there's also a linearity control, this one here, which doesn't really have any effect. It's causing it to get all out of whack. And there's a vertical hold control, which I gotta say doesn't really do much. So what's weird right now, turn this up a little bit, it's very squished at the top, it's very squished at the bottom, but this middle part actually looks fine. These letters are not inverted, and nor are those. I don't know, the whole thing's acting just weird. And I think I'm really feeling like there's a problem here. Wait, hold on a second. Now, that looks perfect. Wait, what? This looks fine. Let's just fill the screen up with text. Has it fixed itself? And you know what? If it fixed itself, that is very indicative of bad capacitors. I checked all the caps though. Uh-oh. Okay, now all the letters are jittery. Something is weird is going on here. Control L. Okay, let's see. You can ignore that it's all tilted. That's just because I took the deflection yoke off there. That's better. Well, I don't quite know what's happening here. It actually looks a lot better, and the jittery is gone. I think I need to plug this into a computer or something so we get some serial port activity on it. But I mean, it's actually looking good. So when I opened the monitor, the linearity control was like this. And the vertical size control was kind of like this. Yeah, this thing has actually fixed itself. It is no longer, it's like there was a short on the lower half of the deflection that's gone away. Whoa, weird. Okay, so let me hook this up to a serial port of some kind so we can actually fill in some text properly on here. And there it is. It's fully operational. It's been running now for about 30 minutes. I have it hooked up to a Raspberry Pi, and it's just working. Like, that fault is just gone. Now, I did check the voltage rails off the power supply. We have 5 volts, about 4.95, so that's perfect. We also have a 15 volts, which I think is what runs the CRT. And then there's a minus 12 volts, and all those 3 rails look really good. I hope the camera's in focus. I just wanted to show how sharp and clear the CRT is. Definitely there's actually a bit more use to this thing than I thought. The CRT is not super strong, but it's overall in really good shape, and it's definitely working. Oops. Oh, shoot. So I ran top, and one of the issues is I have the terminal type set to dumb, which basically has no functions at all. It can't move the cursor, it can't clear the screen, it can't do anything. So that's why top just is continually refreshing the screen. And in fact, I'm pushing Control C here, and it doesn't seem to even exit. How do you even exit out of this? Oh, okay, I pushed Q and that actually did the trick. I meant to do PS-AJX to show all the processes. Anyways, text looks really sharp. This thing, it's working. And I don't understand what the fault was and why it just sort of healed itself, but everything is looking good now. I guess I can just put this thing back together. So first things first, put back this bar here, whatever this is, strengthening bar. And I need to also put the bracket back on that holds that Crt Driver Board in. Ooh, this is a warm piece of metal right here. So the power supply here has a few voltage regulators, that's what these cables are, and they are using this big piece of metal here as a heat sink. So that thing is pretty warm. I pretty much have the belief that there was a problem with one of the caps on the Crt Driver Board, and just running it a little bit kind of reformed the caps. I did test it with my tester. They were okay, but it just sort of came good. Weird when problems like that happen. So one thing that's funny is I'm working on this machine, which is called the Freedom 100, and it is actually the 3rd of July as I work on this. So it's one day before the 4th of July in the US here, which is, as probably everyone knows, Independence Day. So I don't know if Liberty Electronics was an American company, but if they were, the Freedom 100 terminal here has definitely got some patriotic Independence Day vibes going on with it. So there we go, the Freedom machine has been reassembled. Let's put it on its kickstand. Let's see what's happening here. Yeah, I like it. Turn it on. It's in pretty good shape, it really is. It's just such a shame about these broken stems on the keyboard. Now the interesting thing is, I was taking a look at the broken switch down in there, and I thought that it looked a little similar to the switches from the Apple IIe. So I pulled this key off here, and you can see the stem there. Maybe I can zoom in on it. Enhance, enhance. I have no idea if that's actually in focus, but you can see the length of the stem there. Doesn't stick out very far from the key switch itself. And the spring is obviously integrated into the switch because it's not external. But I looked at the design of the switch and I thought, that looks pretty similar to another switch that I thought I might have. And it's the Apple IIe switches. These switches here are from an Apple IIe. And they are definitely the same switch. But the problem is the plunger is far taller on this switch than it is on that switch. So while I have a feeling I could disassemble the keyboard, take the broken switches out, and replace it with these, a friend of mine had given me a stash of, I think 4 or 5 of these switches off an old dead 2E that he had. But that's not going to do the trick because the stem is too tall. And just to confirm that these are the right stems, they're just too tall, let's see if I can put this on here. Yep. That switch, this is that keycap, which is the 6 I took off there, works perfectly on there. It's just too tall. I have these extra switches for repairing a situation exactly like this, but it's not going to do the trick for this keyboard. The old Freedom 100 isn't doing so good. I don't know why this one is a different color. It's just that one. I have a feeling maybe, I wonder if it's harder to push, like it has a stronger spring in it. I can see the switches that are under these other numeric keypad keys are black, just like the rest of them. Let me pop this 6 back on here. There we are. Raspberry Pi in effect. It's running at 9600 baud. Obviously I could have run it at 19.2, and I'm just using a regular USB to serial adapter, the type you could, you know, find everywhere. I think it's, I don't even know, I've had it forever. It's blue color. The screen seems to be brightening up a little bit. Here, I'll turn it down a little bit. Probably what's happening is just hasn't been used in who knows how long. And as this thing is plugged back in, those caps are reforming and CRT is brightening up a little bit. It's just hilarious. It's so hilarious. It just, this thing looks cool, the old Freedom 100. Oh, I just wish I could fix these keys. So I guess that's going to be it for this video. I mean, it was a repair that wasn't, because I didn't really do anything. The thing just fixed itself. And it's 4th of July, and that's pretty cool because it's talking about liberty and freedom in one machine. And I brought this thing back to life. Well, I mean, it fixed itself, bringing itself back to life, but it wanted to live. And all I need to do to make this thing complete is just get 3 new stems. So if anyone has any ideas where to get this kind of key switch, I wonder if there's a name on here. SMK switches, that's what it says on the bottom. If anyone knows where to get the short stem version of these, short plungers, or maybe replacement plungers, I assume these can come apart. Yeah, it looks like these can be disassembled. So I could probably switch out the stem if someone has those. Anyways, yeah, if you know about where to get those, please let me know in the description below. If you like this video, you know, all that thumbs up stuff, subscribe to my second channel. Thanks to my patrons who have been supporting me. I really appreciate it. Check out the main channel, put your comments down below. Thumbs down if you're not into liberty and freedom and you think this video sucks. And there we go. So stay healthy, stay safe, and I'll see you next time. Bye-bye.